Okay, so this is our 3D representation of the aquaponics unit. You can see the growth tray, the growth pipes here where the plants are going to be, right here. See? If you look, you see little holes in there. See little holes? Okay. Sitting above that is, of course, the primary and secondary arm for the robot. It goes down and seeds and harvests and does everything. Like grabbing the plant, cutting it, placing the seed inside a little cup that goes into those growth trays right here. Anyway, these guys. Now, here I've got, you can see the primary arm moving a little bit. I'm going to push it here a little bit. You'll see. See how that moves? Make it go over here. This is an example of twinning in the real world. What I'm doing is here, I'm pushing the primary and secondary arm, and it's showing up over here in the unit, in the 3D unit, the representation. Now the way it does that, of course, is right here. I've got a potentiometer, and that potentiometer is being, the information is being sent to some Arduinos, and those Arduinos are being read by Hal over here on this little unit, this computer. So you can imagine everything that's going on right now. Anyway, here, the way it works and the way I can twin information, and the way I can make that arm show changes is by going through that Arduino, sending that position of the arm through to Hal, and here's Hal Auto, and this is the Arduino representation, and it's right here, and you can see right here the primary arm position, and it's coming in over here. It can vary from 0 to 1,000 something, and you can see it change right there, 834. You can see that value changing, which means that the arm is moving, it's spinning, it's rotating. That rotation over here comes in from here up to a converter. I want that converter to give me a range. Since the range from the Arduino comes in from 0 to 1023, I want that converted to 180 to 0. And I want this information to be sent to Unreal, to my 3D scene. And then in this 3D scene, if you click on the primary arm here somewhere, let me get to it. I have to, there you go. All right, now if you click on the axle, you'll see that the axle is connected to the primary arm position converter. Primary arm position converter coming from that little computer that's connected to those Arduinos. Quite a trip, huh? So it comes in from from the rheostat, the little like volume control that gives me the position, goes into the Arduinos, then goes into HAL over here, into these two little controls. And then you can see these controls here. This is when you click on them, you get the parameters that you can change. It goes from the Arduino into the converter here. From that converter, it jumps over the LAN, or the Ethernet port, because this guy has the address, and that's the address of this guy right here. See? So now I'm talking to that computer, and I'm talking to HAL Auto, and I'm getting this information right here. Primary arm position controller, and you can change that. Right now I've only got these showing, but that's okay. We'll have the lab and everything else going because, you know, it's all here. Anyway, so here I can set what takes place. Now I want that primary arm on the robot to rotate whenever it rotates in the real world. So I can go over, click on animation types, and here I can set rotation range, and if I wanted to rotate on a particular axis. There's 3 axes in the so-called real world. So I'm setting it to rotate on this axis whenever there's a change in this control from that other computer. So you can see the output changes. Right now it's at 45. If you look at the bottom right of that form, you'll see it's 45. I think I've got it relating to degrees. And if I move the arm, see, it changes that bottom right figure. See that? That is going into here. This is the form where you set how you want the information from HAL Auto to affect this actor, this object over here, the robot primary arm axle, which is what I clicked on, right? This guy. Since this guy is connected to it, whenever this turns and rotates on the z-axis, this guy rotates, right? It's pretty simple once you get used to it. Once you get the idea, you can animate any object any way you want, from the real world all the way through to a 3D scene that can be viewed by a whole mess of people all at once. So you can, so that creates the ability for the Omniverse, excuse me. And using Unreal 5.0 now, I have the ability to basically make this scene as complex really as I want. And I can add as many inputs from the real world into any object that I will put in here, and they'll all react according to the real world. And I can use color, rotation, position, sizing, and all kinds of effects, which I will continue to add effects into this scene, and it will be animated from the real, what takes place in the real world. And that's called twinning. Twinning is a method by which you take the real world and you put it into a 3D environment that's animated on a computer that can be viewed in what's called the Omniverse. For now I'll use that name because NVIDIA uses it. And you can watch representations of what is taking place in the real world in a 3D environment, and that gives the ability for everyone to come in and look at, say, graphs or tables or whatever, all kinds of information on what is taking place immediately and what has taken place. So if you look at my last blog, you'll see that the video has a representation of what it looks like to see a 3D animated report, which means that you can look at the information over a long period of time. Say, if you want to see what happened, say at 2 o'clock the night before, you can see a 3D animated video, or, you know, actually it's acting on this 3D scene. You can see everything that happened, say, at 2 o'clock in the morning, if that's what you want to see, or over a long period of time, and you'll see the animation take place, say, in 1 minute over. So you can compress that 16 hour, say, or 8 hour time down to 1 minute, and you can watch what happens over that period of time. So if you had, say, temperature change in your aquaponic tank, and you see it at 2 o'clock, it goes red or it goes like purple, which kind of represents cold, then you know right at 2 o'clock it got too cold, or maybe in the middle of the day you see that it got too hot. So you can see a visual animated representation in the scene of what took place using all of these parameters that I'm sending in. So HAL Auto will be saving all that information, the information we want to save, and it can play back in this 3D scene so that you get a report, in a visual report of what happened over a period of time. So that's it. That's how far I am. I just wanted to show that it does work. Twinning does work, and I'll be using that in the Omniverse, where everybody can come in with their avatars and hang around, and maybe even teach how an aquaponic system works and all the problems that occur using AI and robotics in an aquaponics environment. And yeah, that's it.